5.3, we talk here about three-dimensional representations, and the big thing is isometric drawings, okay? What is an isometric drawing? Well, it's a way of representing a three-dimensional figure on a two-dimensional plane. So we've drawn drawings like this before, but we are going to be using special isometric dot paper, like you see this diagram is drawn on. This is special, there's a special arrangement of dots. The dots are not in horizontal and vertical rows, they're kind of on angled rows like this. So if you were to connect the points, you see the rows that make kind of an X, right? Like they go like this. So they're not up and down and side to side. That's the big difference. And that's going to help us to draw three-dimensional drawings. Now, we have before drawn them without this dot paper, but with this dot paper we're going to be able to draw them a little bit more exactly, and it's going to be a little bit easier to make sure they're drawn to scale too. So you guys drew some drawings to scale yesterday, I know, on that assignment. I saw some of you, and to draw a perfect rectangle with 4 90-degree angles is actually maybe a little bit tough, right? Not with the isometric dot paper. So we're representing three-dimensional figures on two-dimensional paper. So can you grab that door, please? Thanks. So number one, use isometric dot paper to draw a cube with sides that are 3 units long. Okay? So a unit would be the distance between the dots on the paper. All right? So we'll call that 1 unit for now. And so here's the steps to doing this. This is what they suggest. Okay? Start with the bottom corner, the one closest to you. So that would be point A, and I'll change my pen here. Point A right here. Okay? Make sure you draw it at a point on the isometric dot paper that will allow space for your diagram. So don't start at the very top with A and expect to draw above that. Start near the bottom or whatever. Make sure you leave some room for the figure. What else does it say? In each case, make the segment 3 units long, follow these steps. Draw a line segment AB vertically. Okay, it doesn't matter which one you do first. This is their suggestion. Draw AB, so 1, see, to the 1 dot, to the 2nd dot, to the 3rd dot. That's 3 units long. So you draw that vertical line. Draw AC and BD. So AC, 1 unit, 2 units, 3 units long there. You see that? Just connect the dots. And then you can do the same thing over here, and then you can start filling in. Well, there's one side. Okay, well, go along the dots, another 3 units, and there's the top edge and the bottom edge and so on. And then from here, you can kind of see that this starts to fill out pretty easily. So again, 3 units. That's how far you go to get G. 1, 2, 3 for D as well. Okay? So there you go. Now you could envision, you don't have to, but you could envision where kind of the backside is. If this is a solid cube, you can kind of envision 3 units down would be this one. There's the back edge along the bottom. There's another back edge along the bottom. So kind of looks like a, yeah, it looks weird now. No, anyways. Looks like a hexagon piece of pie or something. Okay, anyway, so we'll get rid of those blue lines so it looks like a three-dimensional object again. Okay? So, anyways, yeah, let's see. They throw that angle in there. Let's see. AC and BD at an angle of 30. Counterclockwise from the horizontal. Okay, what you want to make sure is you want to make sure that the sides, the opposite sides of each face would be parallel. Okay? So they're saying don't do this. Try not to do this, where you're drawing a side and you go, hey, I'm going to follow this dot to this one way up here. Well, that doesn't look right, right? It's got to be parallel with the bottom side. So you can't do that. So make sure it's parallel. Okay. Let's see what's next here. We had practice here already. Well, this is just interpreting an isometric diagram here. So let's just get some practice interpreting this. So this one says, I'll just make this a bit bigger for you here. This question says, in the following isometric drawing of a room, the front wall is 18 feet long. Find the lengths of walls X, Y, and Z, and the height H of the room. Okay, so in interpreting these diagrams, now we can figure out relative lengths, right? And so we know that this is 18 feet here. So what you want to do is you want to find out how many feet is each unit, right? So how many units is this Well, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we have 9 units on the diagram, how many feet is each unit? 2. You say 2? 2. 9 times 2 is 18. You see that? So each of these spaces, now each unit is actually 2 feet. So find the lengths of walls X, Y, and Z. So here's X. What is X? X, it looks to me like it's this little piece of wall here, right? So how many units on the dot paper is that? 1. So X is how many feet?
2.
Very good, 2 feet. Awesome. What about Y now? So how many units long is this wall? How many is that?
5.
5. So Y is how many feet? 5 times 2 feet is 10 feet. Very good. Awesome. You guys are getting the picture.
5.
Well, it's 5. So I just showed how we got 10 feet now.
Oh, yeah.
That's all.
Yeah,
So 5 units times 2 feet each.
I just thought it was 6.
Oh, you did? I think it's 5 though, isn't it? Okay, okay. All right, and then Z. Let's use a different color for Z. A little black. Okay. Where's Z now? Oh, here's Z over here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8 units. So Z is going to be 8 times 2 feet each. That's going to be how many feet? Is that wall?
I don't know the answer. I just got a question about that.
Okay, what's your question?
So when we're counting, we don't want to count like 1, 2, 3. Because you're doing 1, 2, is it 1?
Yeah, so I'm counting the space between each dot.
Okay, I'm kind of
Yeah.
Okay.
Yeah. I'm not counting the dots. I'm counting the space between each dot. So I'm kind of starting at the beginning. I'm going 1 space, 2 spaces, 3, 4, 5, 6, 7, 8 spaces. Does that make sense?
Yeah.
So 16 feet is correct. Awesome. Now, the neat thing about this, guys, is look at this. The distance between any 2 consecutive dots is the same no matter which direction you go. Cool, hey? So that's pretty neat. I mean, if you know, not necessarily can you say that with regular, graph paper, let's say. If we had graph paper like this, right, the distance between here and here is not the same as from here to there, necessarily, right? So this distance is not the same as the diagonal distance. So isometric dot paper, pretty cool. An easy way to draw 3-dimensional diagrams as well. Okay. Oh, H. What about the H? I guess we haven't done H yet. So H is the height. So how many spaces is that? 1, 2, 3, 4. So H is 4 times 2. We get 8 feet. Awesome. Okay? So we've got Z is 16, Y is 10, X is 2, H is 8. I should write that a little bit neater. Okay? So I'm going to model this for you. This is what I would like you to do. Make sure it's plain and circle or put a square around your answer. So please make sure that it's very clear, kind of like what I'm doing here, okay? Y equals, you don't have so many colors as me, but anyways, make sure we can see everything on there, and then any work that you would do, throw that on there too, for so I can see what you're doing. Make sense? All right. Okay. That's number 1. Let's take a look. Oh, good. Now we get to draw something on the dot paper. Okay, so we're going to take some time to go through this because this is super important now. So draw the shape below as an isometric drawing on a scale of 1 to 20. Use the indicated edges as your starting line. Okay. What does that mean? Let's walk through that a bit. Make that dot paper a little bit bigger. Okay. So draw the shape below. Use the indicated edge. Oh, this one right here. Okay, so this is the indicated edge. We're going to make this one, okay, the first one we draw. Okay? So if I'm going to draw this 3-dimensionally, we know now with the dot paper, okay, let me see if I can, do I have something that is a prism? Let's see, a square prism? I don't, really. Okay, that sucks. Okay, here's a book, okay? The Concise Dictionary of Mathematics. This is my favorite book in the world. No, I'm just quoting. It's not my favorite, but it is pretty cool. So if you don't know what a math word is in your books, look it up. It might be in here. Probably be here. So if you were to look at this book, okay, straight on, dead on like that. That's not the way we're going to draw it, right? We're not just going to draw the one face. We're actually not even going to draw it like this, where you look at it straight on. We're going to draw it from a little bit from a view that's above and on the corner. So this is what we did with the last one, see? You see how it's kind of like from the corner, we're a bit above. The view is from above the corner and we're looking down sort of on the top. See that? So that's the view. So we keep that in mind. And when I first draw this first little line here, I got to figure out, first of all, how many dots to connect. And then I have to figure out where to draw it. So let's work on the scale aspect of it. So 1 to 20. So if this is actually 20 centimeters in real life, right? How many spaces am I looking for here if I want to make it like 1 to 20?
Wouldn't you just times it by like 20, like 20 times, no, 120 times each one?
Okay, so this is actually 20 centimeters in real life.
Yeah.
And I want to make 1 unit equal to 20
That's
units. Or 1 unit to 20 centimeters. So scale of 1 to 20. Okay. Is there, let's just make 1 unit be 20 centimeters, right? That's what I'm getting at. Okay? And I can't really measure the distance between each of these lines. What's the distance between each of those lines? Is it a centimeter on your paper? Do you think? So close to a centimeter or no?
Yeah, looks like
Do you guys have your rulers with you? Okay, I know I have a lot of rulers here, but do you guys not have any rulers?
No.
Okay, no? Okay, you can't get one? You're supposed to have a ruler. You're actually supposed to have a ruler.
Oh.
You're supposed to have a ruler when you come to school. It's on the list. It's on the list. You guys bring a ruler?
That's the rule.
It's the rule. To have a ruler. Okay. So maybe come up and grab a ruler then. Come up and grab a ruler. Okay, so now that we have rulers in our hand and you've measured the distance between the dots are actually, they're 0.5 centimeters by the sounds of it, right? Okay, so let's make this legit here. So 1 to 20 means 1 centimeter to 20 centimeters. So if the distance between the dots are 0.5 centimeters, right? I need to go 1 centimeter for this edge. On my diagram, this actually should be 1 centimeter. So that's going to be 2 dots. Okay? So I'm going to draw my corner starting here, and we're going to go 2 dots. That's going to be the front edge. Okay? So you go ahead and draw it. Two dots worth. That should be exactly 1 centimeter. Okay? Now, where do you start? Near the bottom, right corner. Okay? I might even have to move that over just a little bit, but we got to go this way, and we have to go, this way, right, with our diagram. Okay? So 60 centimeters. How many dots do I have to go? How many spaces? It's got to remember, it's got to be 1 to 20. So how many centimeters go at 60? So what times 20 is 60? 3 times 20. So 3 centimeters. So guess what? From you guys watching? From here to here, this has got to be 3 centimeters. Okay? So how many units do I go along this edge here? Remember, 2 dots is 1 centimeter. So I need to go 1, 2, 3, 4, 5, 6. That is 3 centimeters. You can measure it with your ruler now. Make sure that's 3 centimeters, okay? So 1, 2, 3, 4, 5, 6. Is that 3 centimeters? Are we doing that correct?
Mm-hmm.
Awesome. Okay, obviously we've got a top edge there too, so let's draw along here. Draw as straight as you can. If you want to use your ruler, please go ahead. And then we close that off, and that's our front edge, isn't it? That's this front edge right here. Okay. So, good idea, probably to do, I'm going to change colors here. Go to red. Let's do this one. This one down here, okay? So that's going to be up on the same angle from this point. We're going to go this way, right? How many units do I have to go? This is 100 centimeters now. So 100 divided by 20 is, well, it's going to be 5?
Okay,
50? So 5 centimeters, okay, 5 centimeters. So how many dots do I have to go? How many dots do I have to count? Remember, we're 0.5 centimeters per space, so double that. Okay, 10, good. So 1, 2, oh boy, this is going to be hard for me with my tablet here. 3, 4, 5, 6, 7, 8, 9, 10. So that should be 5 centimeters. So let's start labeling things here. 5 centimeters. We said this was 3 centimeters. This is 1 centimeter. Okay. Okay, you guys getting the hang of it? Okay, let's do the 40 part. So again, 1 to 20, so that's going to be 2 centimeters, right? And that's going to be how many dots, how many spaces? Right on, 4, you guys are getting it. 1, 2, 3, 4. See that? Make sense? Okay, let's go along the back edge here. How long is this? Well, that's going to be the same as this edge right here. So it's going to be 60, which is 3 centimeters or 6 spaces, isn't it? 2, 3, 4, 5, 6. So you see how this is starting to shape up here now? We've got 60 centimeters again here, so we haven't done that one yet. We may as well do that one here real quick. So that's 60 is going to be 3 centimeters, so that's going to be 6 dots. 1, 2, 3, 4, 5, 6. And it's a square, so I'm going to make the same length over here. And hopefully you're seeing how this is shaping up now. This is going to get pretty easy now. And we've really only got one more face yet to do. And this one, I don't know, is this one going to go through the dots there? Well, it's maybe going to go through one dot, not all of them. I think it's going to go through that middle dot if you draw a straight line there. So it should go through, I think, one dot in that whole thing. See, the one right there. Alright, so we've got, this is 2 centimeters, this is 3 centimeters, 3 centimeters, and so on. Now we could figure out the length of these here, but we don't have to. It's not given, so it's okay. Okay, so any questions about that? So isometric dot paper is actually really handy for drawing three-dimensional diagrams. Really, really handy. We had to do this. We had to do this without dot paper before. You remember how hard that was? So to draw something like this, we would kind of have to go, okay, well, I'm going to have to do this and this, right? You're going to have to kind of, and it was kind of hard. Okay, where's the parallel lines? And, oh, this has to be parallel to this one. And then, oh, this has got to come down the same, parallel. Oops, you see how kind of tough that was, right? To do it like that. So isometric dot paper makes it pretty perfect. Okay. Any questions about that? Okay. So this is 0.5 centimeter isometric dot paper. We'll have to keep that in mind. Okay. All right. So I'll give you guys a few minutes to do this one on your own. And this one says, use an appropriate scale, draw an isometric image of the storage unit using the indicated edge as your starting line. So that's this edge right here. Okay, the starting line. So you go ahead and see, show me what that kind of looks like. So again, this is a different perspective on this one, right? We're kind of looking at it from this angle here. So see what you can do there. Go ahead. Okay, so when doing your scale there, if you pick 10, okay, Curtis, just hang on for a second. If you pick 10, that means that this height right here has to be 12 millimeters. Is that going to be easy to do on this dot paper? You probably don't want to make it 12 millimeters. Sorry. You're probably going to want to make this either 1 or 2 units tall. You see that? So, right? So this edge right here, let's say it's 300 millimeters. So I tell you what, let's do this. Let's just start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if we use 10 units for that whole thing, what scale is that? That's actually 5 centimeters, right? Or 50 millimeters. So if I went 300 millimeters, what would I have to divide that by to get 500 millimeters? You see what I'm saying? This is going to be your scale factor then. So what's 300 divided by what gives you 50? Okay, 5 times what gives you 30? Do you know that one? 5 times what gives you 30? 6. So what's 300 divided by 6?
50.
Okay, so this is 6.
So I sent the scale factor of 60.
So you did 60?
Yeah.
What if you did 1 to 6? Would that work? So 300 millimeters, what is that? What do I have to, what is this number here? Right? Or 1 over 6 equals x over 300. What's that? That's 300 times 1 is 50.
That's 50 millimeters.
50 millimeters. So that's what we've made this line.
That's
5 centimeters.
Oh, what, if you,
So here's your scale. Okay, I'm just going to help you out with this one. Here's your scale.
doing 60 is the same thing. Gave me the example.
Well, no, 60 would have taken you to centimeters then, I guess.
Yeah, I'm just putting that.
Yeah.
I'm okay to do that. I'm willing to do it.
Well, here's the thing. If 1 to 60, this is not 1 to 60 though. Because if this is 5 centimeters, then, right, 60 would be 300 centimeters. Not 300 centimeters, 300 millimeters.
Oh,
Okay? So it's 1 to 6. That could be your scale. Okay, go ahead and start there and finish the rest of that diagram. Okay?
how is it in this one?
So just as you further figure this out, each unit then is 30 millimeters. Okay? So if we've got 10 units here for 300, that's 10 times 30 is 300 millimeters. So each unit is 30 millimeters. So for this edge right here, which is 90, that's got to go 1, 2, 3. Make sense? Okay. All right, guys. So yeah, your lines should be straighter than mine. I can't really use a ruler on this tablet here, but make sure they're nice and straight with a ruler if you can. So this is how it should look if you had the different perspective. So you might have looked at it from the other angle. So instead of looking at it from this side, you might have looked at it right from, like from this side here, right, instead of from the top side. So that's fine. If you had it shifted this way instead, that's okay. So as long as the lengths are proportional, okay? Any questions about that, guys? Nothing? Okay. Okay, so the big thing is make sure it's the same shape, right? It's got to be the exact same shape as the diagram. Then you know you have all the sides proportioned properly. Okay, so let's take a look at the second part here, perspective drawings. Okay, we need to talk about perspective drawings. And in perspective drawings, it's a drawing that tries to represent objects as we actually see them. It uses the idea that parallel lines appear to intersect at a point on the horizon line. The point is called the vanishing point. How many of you have ever done art before? Done art before? Taken an art class? No? No one has? Okay. So you have? Caleb? You have?
Mm-hmm.
Okay. So have you ever done this? Like a vanishing point or like a perspective drawing? You ever done a perspective drawing? You think you have? Okay. So when we look at something, right, the front face or whatever's closest to us appears larger than whatever's farther away, even if they're the exact same size. That makes sense, right? A person standing right in front of you is bigger than a person standing down the street. It's obvious. So if we were to have a really large object, like a building or something, and it was a really long building, the way we would actually see that would be the front of the building would be bigger than what appears to be the back of the building. And so we would have a drawing that looks something like this, right? Things kind of like, as they get further and further away, they appear smaller and smaller. So that if this was the front of a building, and this building were an infinite number of meters long, then it would appear that the backside of the building, even though it was the same shape as the front side, would appear to be a single point. Okay? Paying attention up here, guys, okay? So, we need to use this idea of a vanishing point in order to draw a perspective drawing. Okay, so the horizontal is just a horizontal line here like this, right? The horizon line. And it's not always visible. You don't always have to draw a horizon line, but you do need to have a point that would be somewhere on the horizon line. So let's take a look at this. Use perspective drawing to create an image of a rectangular prism. So again, we don't necessarily want the prism to look kind of like we've been drawing them, where the back side is the exact same length as the front side and all that. Like, we don't actually want that. What we want, so here's what we want. We want, if this was this long, we want the back side to be a little bit smaller than the front side, because that's exactly how we see it. You see that? Now, what guides this sort of drawing? Well, it's actually that horizon point. So notice this. All of these lines go from the corners to the horizon point. And now I'm a little bit off there, but check this out. If you were to draw a parallel line somewhere back here, parallel with this, and a parallel line to the side, that would sort of be your three-dimensional drawing of a prism, rectangular prism, like we would actually see it. Okay? So here's some examples of perspective drawings, okay? So you look at something that's really tall, right? It appears to kind of go up to a single point. Or something that's really long, like a hallway or something. You see how all of these lines are not parallel with each other. They are all tending towards some common point in the middle. Even these lines right here, right? This is kind of, we have a front edge here, and it's kind of going away. All of these lines right here are tending towards some vanishing point that would be on the horizon. You see that? Okay. Now, if the, there's a good one. Okay. Right? So you have some vanishing point, and you have a straight line between every corner. Right? Every corner. Here's another one. So you kind of get the idea. If you use these vanishing points, you get this drawing. Here's an X on this one. This one's interesting. There's two here. You see how these lines right here, these lines actually would connect with this X, connect with this X, connect with this X, and then the other lines would connect with another X. So you get this sort of perspective of a street corner. See that? There are two perspectives, or two horizon lines. Anyways, okay, let's get back to the notes here. You guys with me so far? So here's the finish of the rest of the example. Okay, perspective drawings. Then, of course, you would erase the back little piece there with the point, and there you go. That's your perspective drawing. Okay. All right. So you each have a ruler now. My ruler. So you have a ruler. So connect each corner with the points here for number 4. Okay, and it says draw 2 perspective drawings of this rectangular prism using the 2 vanishing points given. Do your 2 perspective drawings look the same? Why or why not? Okay, so remember to kind of draw a backside somewhere as well, and then erase your pencil line. So you should be using a pencil. Okay, use a pencil so you can erase, just like we did on this one. So here is your model there, right? That's how you do that. Okay, take a few minutes and work on that. Okay, so this one's not very neat, but you kind of get the picture. Then you would erase the sort of the lines behind the figure as best you can, and there's your figure. So do that again for B there. Okay, so it'll be easier for you guys probably with your rulers and that, but every corner goes to B. and try and make them straight, not like mine. So every corner goes to B, and then you just kind of cut it off somewhere there, draw parallel lines to the front edges and to the sides as best you can. And then you can erase everything behind. Okay? So do your perspective drawings look the same? Well, they don't look the same. They're not identical because we have different vanishing points, right? So this is like we're viewing this thing from a different perspective. Think about a drone, right? A drone. If you were to fly a drone above a building and have it looking down on one corner of the building, you would see it one way. And if you flew that drone over to the other corner of the building or beyond the other corner, then you would see it a different way, and so on. Okay? So when you're done that, go ahead and tackle 5. It's got a few extra corners there. So do the same thing with 5 and just kind of work on those drawings. And when you're done 5, you can do 6, and then we'll pick this up. This will probably be the next section here. Okay? So finish all the way up to 6. Okay?